Okay, so let's start. The diagram below shows a device designed to compress a crushed material for school science project. So this is the device that we have. As you can see, this is a hinge. The distance from a hinge to the force here is about 10 centimeters, and the distance from here is 65. Let's go to question A. State one condition necessary for a body to maintain equilibrium. 1 mark. So we are getting the answers from principles of moment. What are the conditions necessary for a body to maintain an equilibrium? So you can say the condition necessary is that the clockwise okay. So the clockwise moment should always be equal to the anti-clockwise moment. Let's go to B. Calculates the moment of the 5 Newton force about the hinge. So we know what moment is. Moment is equal to force multiplied by perpendicular distance. Do we have the force? Yes, from the question they're saying calculate the moment of 50 Newton. So you're going to write your 50 Newton here multiplied by the perpendicular distance. What does that mean? It means the distance from here, the hinge, up to where the force is acting. So you're going to add 10 plus 55, which is going to give you, so let's find the value of D. So we're going to say 10 plus 55, we're going to have 65 centimeters. Now, we're going to convert 65 centimeters into meters. So we're going to divide 100. So when we divide 100, we're going to have 0.65, okay, meters. So this is the perpendicular distance. So you put your 0.65 meters here. Okay, this one is Newton. When you multiply, you're going to have something like okay, you are going to have 32.5 Newton meter. Okay, so this was the moment. Let's go to C. Calculate the upward force. As you can see, there is an arrow there showing an upward force which the crushed material exerts on the piston to keep the beam in equilibrium. So, see, we're going to calculate the upward force. What are we going to do? We know that moment 1 is equals to moment 2. Okay, which means F1 G1 is equals to F2 G2. So we're going to use the same formula for principle of moments. How much is our F1? Our F1 is the one that we're looking for, multiplied by our D1. So where I'm getting these things is from here. The F1 is the force that is exerting downward here on the piston. The force that is going downward here. So is the one that is going to be the F1. And then the distance from the hinge to where the force is acting is 10 centimeters. If we convert that 10 centimeters into meters, we're going to have 0.1 equals F2. F2 is going to be 50 newtons. So we're going to put the 50 newtons there. Multiplied by the distance, okay, from the pivot, from the hinge up to where the force is acting. This we have already done, so I will not spend much of the time. We've already calculated it there. So after doing that, we'll multiply. We're going to have 0.1 F1 equals when we had we multiply these things, we're going to have 32.5. Okay, let's divide 0 0.1 such that 0 0.1 and 0 0.1 cancels each other. When we divide, we're going to have 325 Newton. Okay, this is the force that is acting downward. Therefore, the question is that we should calculate the upward force, not the downward force. So we're going to say, therefore, upward force is equal to 325 Newton. Why? Because according to Newton's third law of motion, okay, to every action, to every downward force that is going, the downward force, there is an equal and opposite upward force acting on the opposite direction. So there is this opposite force acting upward. So that's why we're saying upward force is equals to 320. Do you have any more questions? No? Thank you very much for sticking around, guys.